Hey, what's going on, guys? It's solution day and one more week and some interesting discussions over the last week regarding some questions. One of them is this one: if fx minus f of minus x equals 1, which of the following fx there is only one solution to the above equation? It's quite interesting of a question. It may confuse some into thinking that these equations, they just cannot even be solved. But the first appearance that comes to mind isn't always the right one, you know. It's another one of those questions where you have to conceptually understand these functions. The question is asking which one of the following option has only one solution to the above equation, meaning it may have multiple solutions. So let's start with the option A. 1 plus absolute value of x. So if we substitute the function the way it wants us to, so 1 plus absolute value of x minus 1 plus absolute value of minus x. Now the absolute value of minus x is the same as the absolute value of x. So in this case there won't be any solution to it because the x and x would cancel out, and 1 and 1 would cancel out, so 0 not equals 1. So that's definitely not an answer for our question that we're looking for. Now, the question was asking which of the following has no solution. That may have worked. But A is ruled out, so that can't be the case. Let's start with e to the power x. E to the power x is the fx minus f of minus x. So that would be e to the power minus x. E to the power minus x equals 1. So, which is the same as writing e to the power x minus 1 divided by e to the power x equals 1. Now, this is starting to go somewhere. If we simplify that, let's multiply the whole equation by e to the power x to sort of turn this into a quadratic. So, e to the power 2x minus 1 equals e to the power x, which gives us e to the power 2x minus e to the power x minus 1 equals 0. Now, if we substitute e to the power x equals t, we'll get t squared minus t minus 1 equals 0. So that gives us two solutions. If we put the quadratic formula, we will get t equals half 1 plus minus root 5. Okay. So we are getting a solution, but one of these values, e to the power x, is negative, which can't be. E to the power x will never be a negative value. It's always greater than 0. It's actually never negative. It's greater or equal 0, but it will never actually be negative. So we can rule out the solution that's giving the negative value for t, which in this case would be one of these values, because 1 minus root 5 is obviously a negative value. So this one will only have one solution, which is t equals half 1 plus root 5. And the solution 1 minus root 5 is ruled out. E to the power x is not less than 0. It's greater than 0. So that was that. But let's just try to rule out what the other options are. 1 plus sine x. What does that do? So 1 plus sine x, we do 1 plus sine x and then minus 1 plus sine of minus x, okay, equals 1. Sine of minus x is minus sine x. So then this identity will change into 1 will cancel out. Minus sine x, this will become 2 sine x equals 1. So x equals 30 degrees. Now that's our first solution, but we do know that the sine x, they are periodic. They have a period, and these values repeat. Like it'll be 30, then it'll also be 150. So technically the solution is pi by 6 plus 2 pi n, or 5 pi by 6 plus 2 pi n. So those are your solutions for that. So obviously it's more than one solution, even though it's tricky. Right out the bat, we're looking at, hey, it is a solution, 30 degrees, it's the answer. You could pick that. If you're not able to resolve the e to the power x the way I did it with the quadratic, you could think, hey, this is two solutions and move on and get this the answer. But no, that would be incorrect. E to the power x is the correct solution. Same thing with 1 plus x squared. 1 plus x squared, now x squared is always going to be x squared, whether it's minus f of x or, if it's f of x or f of minus x. So then 1 plus x squared minus 1 plus minus x squared equals 1. So x squared will cancel out because minus x squared is x squared, 1, 1. So again, we run into the no solution scenario. There's no solution for this. So this one has multiple solutions. This one has no solutions, but they're both out, and obviously this is not here. So this is e to the power x is our correct solution for this situation. Very interesting question and some very good discussions regarding this. Some good discussions where e to the power x, those who could actually solve e to the power x using a quadratic relationship didn't eliminate the negative choice. And there were some of you who solved it with the 1 plus sine x identity. It gave me C as the answer. Those are also very smart answers, but this question goes beyond that, just one step more in the conceptual understanding. And that's really where the perfect score and the high ranks lie. So the next question I want to go over today is the area of a triangle that is in a circle. It's a circumcircle of a triangle. So what's happening here? A circle with center C and unit radius is shown above. Which one of the following graphs could represent the relationship between the area of the triangle and the angle x? Okay, so in here, this triangle is isosceles. You've got these two, they're the radius of the circles. The both angles will be x, the middle angle will be 2x. So your triangle is sort of like this, 1, 1, and 2x. So what's the area of the triangle would be? Half sine 2x times 1 times 1, AB sine C. That's the area of your triangle. So what is that? So we've got, it's sine 2x because it's pi minus 2x. I missed that part. So pi minus 2x, because you have x, x. These angles are x. This angle is x. So this middle angle is pi minus 2x. So which is why sine of pi minus 2x equals sine 2x. That's why I did it that way. So that's your area. Now sine 2x is a function that is periodic, and its maximum value is at pi by 4 because sine 90 equals 1. So anything that has a value that is not at pi by 4 is actually already eliminated. So the question should resolve itself fairly quickly. So this choice is out, this choice is out. So we're left with this one has a maximum value at pi by 4. This one has a maximum value around pi by 4. So which one of these is true? So we have to look at the actual value of it. So we've got a half in there. And this one, the bump right here is about 1. So this thinks the area is 1. And this is the case where the area is about half. So this would be the correct answer. And the next thing we have to think about is the domain of it. On the domain of it here, the value of x, of this x here, is going to be, it's going to go from 0 to 90, because it's going to go from 0 to 90. The radius is going to circle around. The minimum value is 0, maximum value is 90. So that's sort of the domain of the function. So it will only be at that value of 0 to 90. So that would define this question. So that's that. Again, really good feedback for things, and I'm working on my book. The book that is called Ahead of the Curve is going to feature a great deal of questions that are highly conceptual and their solutions, and some concepts that we have learned from great teachers over the years. I'm going to compile that all in one book, and I'm working slowly towards that book, and you guys are helping me with giving feedback for the questions. And like I said, it's not just designed to prepare you for a test like IIT or ACTs or SATs. It's that. It will help you, but today the dynamics of the standardized testing is changing. So we don't know what we're going to be up against. Some of these questions, if you go apply for a research job at a college or something, the interviews could ask you really highly conceptual questions. And even some schools are considering doing their own tests. So we don't know the future of standardized testing. So it's even more reason to build concepts. So you understand the concepts and not just tips and strategies to do well on a test. And that's part of these questions. The initiative is to get the concepts really strong, not just polishing the tricks and strategies for one type of question. And that's kind of where I think the future of standardized testing is going to go, is that it's going to change eventually, and it's going to rely more and more conceptual. So interviews, things like that could happen online through a Zoom session. The future could be, you could be sitting with an admissions officer. It could be a sort of a vocal interview, and you have to know your stuff. Some people are great with tests, some people are great with concepts. If you bridge the gap, things are going to get interesting. So anyway, I digress. So next week I'll come back with some solutions to the questions and some lectures about things. Some people have asked me to go into the details of some mental math tricks, and that's another topic of video that I would make, explaining, are the mental tricks actually necessary? Are they helpful? How much are they helpful, or is it all a myth or a party trick? So we'll cover that next week. Thanks for watching, guys.